I have your exam result and I sent you email. Most of you send me email to get your grade. You can send me anytime, email anytime and ask for your grade. Homework due date is next Tuesday, and I'll finish mesh today so you can solve all homework problems. Anything else if you have any question? And also the tutoring time, because some students, they asked me to move it a little bit late. I contacted the tutor and he agreed to have the tutoring same day Tuesdays from 3 to 4 instead of 2 to 3. Again, as I said, I cannot assign tutoring time because these are, it's up to the grader. Up to the tutor, TA, to assign their own. Okay, do you have any question before I start? Today we are talking about mesh. I'm going to use class participation because it's important, but first I'll show you 2 examples without class participation. So please pay attention. Mesh and nodal, these methods you learn much better if you pay full attention to the procedure. And then I'll go around and ask class to participate and do more problems related to mesh. And if you have any question related to mesh and nodal, at the end you can ask. So we can wrap up this chapter. It's a short chapter. It's chapter 3. If you're reading a book, it has only 2 methods. And then mesh and nodal. So let's just start with mesh. Do you have any question before I start?
I had a question, but I wrote it down and I can't find it right now.
We can ask later. We can ask. You can stop me later and ask questions.
All right, thanks.
Okay. So let's just start with mesh analysis. Paying attention to the process, especially at the beginning, is important. I know that some people join late. Some people just join and they go away. But again, this is for your own good, because based on what I've seen in the exam and based on what I hear sometimes when I go around, I'm not saying everybody, but there are, several students that even though they log in and they are attending, it shows according to the Zoom, but because it's not classroom, I can tell because I'm looking at you, I see you in class. But here, I can't tell if you're listening or not. But the problem here is many students, maybe they don't listen carefully. They depend on notes, maybe even Google search or reading books. Circuit analysis is one subject area in engineering that it's very systematic. Systematic means it's guideline based, it's rule based. So if you know the guideline and if you can apply to multiple problems and get the good understanding of the guideline, you can apply to any subject. There aren't too many special cases or weird cases. So the setup is always the same. And also when you take, it doesn't matter if it's a small circuit or large circuit, the setup is the same. The most important thing here is the setup. You must have correct equations. Remember, solving in circuit analysis, we have two general steps. Step 1 is to set up the equation, and step 2 is to solve the equation. Solving equation is the math part. You can use your calculator, you can use some kind of programming to solve equations, even though these are algebraic equations. But setting up and finding equations correctly is the most important aspect of circuit analysis. Mesh is also same as nodal, is bypassing equations. Like if you want to apply KCL, KVL, you end up with many equations, many unknown. You can bypass many of them, and you can reduce the number of equations unknowns. I showed you with nodal, one of the examples that if you apply KCL, KVL, you ended up with 5 equations, 5 unknowns, but with nodal, you only had 2 equations and 2 unknowns. Same thing with mesh. Mesh overall, appearance of mesh, is based on KVL. You must apply KVL. Number 2, the appearance of mesh equation. Mesh equations. You only see voltage quantities, like for example, V1, V2, V3. So when you look at the equation, you only see voltage. There is no I. So you only see voltage variables, not current variable. Remember in nodal, on the side, nodal was based on KCL. And in your equation, remember you had like, you used I1, I2, I3. So that's the difference between nodal and mesh. For nodal, you're using current. Actually, let me, sorry. I have to correct myself. For mesh equation, you only see appearance. You're using voltage. You're using KVL, but your final equations are based on I1, I2. So you only see I1, I2, something equal to something. These are the equations. In mesh, you apply KCL, you write current equation, but at the end, remember, it's V1 minus V2 divided by something, V2 minus V3 divided by something. So you see the voltage quantities. These are the main differences. For KVL, applying for mesh, you see current at the end. For nodal, you see voltage at the end. So you're solving multiple equations, multiple unknowns to find voltage in nodal. You solve multiple equations, multiple unknowns to find current in mesh. Many students, they find mesh easier than nodal. Which one is better? It depends on the circuit. For some circuits, maybe nodal gives you fewer number of equations. Some cases, mesh gives you fewer number of equations, but they are both much better than general applying KVL KCL. But notice that they are based on KVL KCL, except you bypass some equations. So let's start with mesh based on guidelines. So these are the guidelines. First of all, forget about the question. Ignore the question. So mesh is independent of the question. If I give you a circuit and you want to apply mesh, it doesn't matter what question I ask at the end. It's the same set of equations. That's a good thing. That's why I mentioned before that it's systematic. You can vary your equation, but you can vary your questions, but equations are the same. Okay, in mesh analysis, after you forget about the question, start with clean circuit. Specify all simple physical loops. Physical loops are the loops that you're passing through circuit element. Number 2, assign not individual current, loop, for the entire loop, current to each simple loop. Okay, and label. And you have to label and label. For example, I1, I2, I3, or IA, IB, IC. You can use lowercase, uppercase, doesn't matter. If it's time dependent, I mean, at this point, we are not covering time. You can use lowercase, uppercase, that's not important. Number 3, assign voltage polarities to all same passive elements only. So if you have a current source, don't assign voltage. Voltage is not 0, but don't assign it. Only passive elements. And very important, do not label. For example, don't call it V1, V2, V3. Just put polarities. Just polarity. Do not label. Don't put any V1, V2, V3 next to it. Number 4, okay, you're ready to write equations. For equations, now you're ready to write your KCL equations. For equations, start with current sources. You will see What do I mean by that? You will see later. I'll give you an example. Start with current sources. So this is for equation. Then apply KVL to any loop without current sources. Any loop that you don't hit a current source, use that loop to write a KVL. Okay, number of equations that you need, number of equations, same as nodal, should be the same as number of loop currents. And you're done. For example, if you have 3 loops, 3 loop currents, you need 3 equations. If you have 2 loop currents, you need 2 equations. Any question about the guideline without showing anything? Of course, I have to show you circuit in order to understand each guideline. But do you have, I mean, the guidelines are also given in the handout. So if you don't have time to write them down, actually my writing here is much shorter. I mean, it's shorter than what I have in my handout, or maybe the same, I don't know. But anyway, you have it in the handout. So you forget about, you just have 3 preparations, ignore about the question, specify simple loop, assign loop current, assign polarities, and you're ready. You're ready for what? To find equations. First, use current sources. After that, go to each loop that has no current source on it, and then write KVL. When you have enough number of equations equal to the number of loop currents, then you're fine, you're done. And then you're ready to solve the equations. Okay, so let's do that. And please stop me. At this point, I'm not going to, I'll give you 2 examples without involving you. Then I start examples involving the whole class, maybe multiple times. Today, I'm devoting to finishing, wrapping nodal mesh. And why do I spend so much time on these 2? Because they are the main 2 circuit methods. If you continue in power area, you will see later in power, with transformers, with power circuits, you have to, with three-phase transmission line 3-phase, you have to use mesh. If you continue in electronics, you will see that in many cases in electronics and non 3-dimensional circuits, you have to use nodal. Otherwise, it's very confusing. So that's why you need to know these 2 methods very well. Okay, so I'm going to clear my guideline, and then I keep repeating them anytime I'm using circuit. So let's just start with equation. I mean, these 2 examples are from handout. So I just put handout, you don't need to write them. If it's not without handout, I mention and then you write it. But these 2 examples are from handout. Example 1, the following circuit is given: 6 ohm, 3 ohm, 4 ohm, 2 ohm, and then I have 2 voltage sources at the end. Here we have 3 volts, and I have a voltage source here, 8 volts, and this is connected. And then I have 6 ohm, 2 ohm, 3 ohm, and 4 ohm. Okay, problem is, at this point, I just want, regardless of the question, I probably put the question later. Maybe I can put the question here. This is the question. I put it in red color. The question is, for example, find V0. So the question is find V0. Okay. Without mesh or nodal, if you want to write all KCL, KVL, you end up with 3 equations, 3 unknowns. You have to write 2 KVL equations, 1 KCL, and you have to assign voltage, current, and label voltage, current to all passive elements. Here I want to apply mesh. Okay, with mesh, first of all, you remember this was V0. Forget about the question. So redraw the circuit without question. I'm going to erase my question. Okay, specifying simple loop. Simple loop is a loop that when you go around, there is no circuit element inside. This is a circuit loop. I mean, this is a simple loop. This is a simple loop. We have two simple loops. Assign loop current and label. What direction? Any direction. Do you want clockwise, counterclockwise? You can make one of them clockwise, one of them counterclockwise. Doesn't matter. Any direction. That is very important. Any direction. I choose in this case. So at this point, you don't even consider anything. You just any. I always say that any direction your hand is moving, use it. I'm going to use both clockwise, and then when I go around for other examples, you can choose your own direction. You can use lowercase, uppercase, because this is DC, it's okay to use uppercase. But that's, again, it's not an important issue. So anything related to mesh, I use blue color. Assign a loop current. So these two currents, they go around. Now you go to, this is a preparation process. Assign polarities. Only passive elements. I just put the key words, passive elements. Again, no consideration of passive sign, non-passive sign, nothing. Just put plus or minus. Again, if it's not given in the problem, you assign anything. For example, I use plus, minus, plus, minus, plus, minus, plus, minus. Don't label. Only passive elements. I have 1, 2, 3, 4 passive elements. I have 4 resistors. Put polarities, any direction, any polarities you want. In any arrangement you want. Now you're ready to write equation. First, check to see how many equations you need in this case. You need 2 equations. Why you need 2 equations? Because you have two unknowns here. Because you have 2 loop currents. But they are unknown, I1 and I2. If I had 3 loop currents, then I needed 3 equations. So I need 2 equations because I have 2 loop currents, 2 unknowns, I1 and I2. In order to write, this is not equation. How do you write equations? In order to write equation, use current sources. First. In this case, for this problem, there is no current source here. So you bypass this one. Now write KVL. For each simple loop without current source. Okay, we have 2 simple loops. So you have 2 KVL. We have loop 1 KVL and you have loop 2 KVL. Loop 1 KVL. Have a quick assessment of voltage rise, voltage drop. Rise, any direction. You don't even have to move along the direction of your loop current. That's the key. Anything for each step, you have option, any direction. I don't know, for me, it's more comfortable to move in clockwise direction. Doesn't matter. Okay, so voltage rise, drop, drop, drop. So I have 1 rise. I put it on the left. Doesn't matter. Drop, drop, drop. For drop, I immediately use Ohm's law. What is this voltage? Ohm times amp. What amp is passing? I1. Is I1 passive sign arranged? Yes. Move your hand. I1 goes from plus to minus. So it's 6 I1. Plus, what is this voltage? 3 ohm times current. But this is a branch that is shared by 2 loops. So 2 currents are going, passing through 3 ohm. Which one agrees with passive sign? I1. I2 is against passive sign. So I have 3 ohm times I1 that agrees with passive sign and I2 that is opposite passive sign. And then continue. Plus 4. What current is passing? It's a single branch. I1 and I1 agrees with passive sign. If it disagrees with passive sign, you just put minus I1, for example. In this case, agrees with passive sign. It's equation. You can just write any way you want. So you have a voltage rise, drop, drop, drop. And for each voltage, you apply Ohm's law, 6 times I1, 3 times I1 minus I2, and 4 times I1. This is your equation number 1. Let's do equation number 2, and then you can ask me any question. Let's go to loop number 2. You can start any point, doesn't matter. Let's start with 3 ohm. It's rise, drop, drop. What is this voltage rise? It's 3 times I1 minus I2 equal to 2 ohm I2 plus 8 volts. You get 2 equations, 2 unknowns, and that's it. Now you ask any question you want about mesh equation. These are mesh equations. Of course, you have to rearrange them and make them, reorder them and everything. Those are the math part. I'll do it later. But at this point, you have any question?
Professor, I'm just a little confused on the second equation you just wrote.
You tell me, what is KVL here?
KVL is, I wrote it as 3 I2 minus I1.
Why I2 minus I1? I2, did you change your I2 for circuit 2? I2 goes from minus to plus.
Yeah, so since it's going clockwise and also the I2 is going clockwise.
Wait. No. Why do you write I2 minus I1? I2 is against you. You didn't change anything in your circuit. Why you want to violate Ohm's law? I2 still goes from minus to plus. So why it's I2 minus I1?
Because of the arrow. That's why I got confused. The arrow goes in the same direction. Okay, you're in this loop. Doesn't matter. Regardless, forget about loop 1. You're in this loop. Think about this loop. Okay, first you check polarities. What's the polarity arrangement? Voltage rise, voltage drop, voltage drop. So you have these 2 voltages on one side and this one on the other side. Now you pay attention to Ohm's law. What is Ohm's law? O times amp. What is amp? We have 2 currents that they have opposite direction. Which one agrees with passive sign convention? I1. Which one disagrees with passive sign convention? I2. So it's 3 times I1 minus I2. I don't understand why you say I2 minus I1. If you say I2 minus I1 means that if you go to loop number 2, you switch polarities. You're not allowed to do that. Once you set the polarity, you should keep the same polarities. I1 goes from plus to minus. So, okay, if you didn't, why you say I2 minus I1? Because before you taught it to us like that, that was just my intuition.
What did I teach you that it's your intuition?
Just right now, the way you taught it to us, the I1 minus I2, that way makes sense. But my intuition said I thought incorrectly about it at first before you taught it to us.
Okay. Is this clear now?
Yeah, because we're going in the direction opposite to passive sign convention. I2 is negative and I1 is positive.
Again,
so
I'm trying to know.
I2.
Again, you still have a little bit of incorrect intuition. Why? Because you say we are going against. It has nothing to do with our movement. Let's say we move this direction. Let's say we have this loop and you're moving in this direction. That's your movement. It's a voltage rise, voltage drop. That movement defines which ones are rise, which ones are drop. Your movement. So summation of these 2 equal to this one. Then you're done with your movement. When you're thinking about Ohm's law, it's 100% purely based on individual resistor, current and polarity, current direction and polarity. So for example, regardless of your movement, what is Ohm's law here? Your move has nothing to do with the direction of the current. You assign current in this direction. If you want to confuse yourself, You can assign current in this direction, but move this direction. Doesn't matter. Your move just determines rise drop arrangement. Ohm's law is the actual current and actual polarity. So regardless of your move, what is Ohm's law here? 2 ohm times I2. I2 goes from plus to minus. So it's 2 ohm times plus I2. What is Ohm's law here? 3 times the current. I1 agrees, I2 opposite. So it's 3 times I1 minus I2. So it doesn't matter how you move around the loop. Ohm's law, again, I don't know how to say it. Maybe somebody else can elaborate a little bit better than I do. Movement identifies the arrangement of voltage rise, voltage drop. I mean, for example, in this case, I said it before, I'm going to say it again. And I think, and the reason is some students, they get confused about KVL because they don't do this systematic way of thinking. Okay, when you move, let's say move, moving has nothing to do with the direction of current. It's you're moving around the loop. So if you move here, let's label for a moment. Let's label. Let's say this is V1, V2, V3. For a moment, let's label. Okay, if you move, your movement has nothing to do with the direction of the current. You've decided to move from right to left around the loop. You have rise, rise, equal to drop. You have rise, rise, equal to drop. Suppose you move in this direction. Then you have rise, drop, drop. Rise, drop, drop. It's the same thing. So movement is just changing your word from rise to drop or drop to rise. Has nothing to do with the Ohm's law. That's your movement. Now, when you're substituting values, V1 is 8 volt, it's given. V2, you're done with your equation. What is V2? Ohm times V2. It's ohm times amp. Now you have to look at the direction of the current. If it agrees with passive sign, it's plus I. So it's 2 times plus I2, because I2 agrees. What is V3? Ohm times amp. But I1 agrees with passive sign, I2 is the opposite. If they both move in this direction, they both disagree. So you have minus I1 minus I2. If they both move from top to bottom, then you have I1 plus I2. If I2 moves in this direction, I1 opposite, then it's I2 minus I1. It's purely based on passive sign when you use the Ohm's law. Any question? Okay, so the next step is to rearrange the equations. Would you please mute your mic if you don't have any question? Okay. You have to write them in organized format. So you put all the KCL after writing KCL, all I1s together. So you have 6 plus 3 is 9, I1, minus 3 I2, oh, sorry, 13 I1. Six and 3 and 4. Minus 3 I2 equal to a constant 3. And then we have 3 I1, bringing I to this side, it's minus 5 I2 equal to 8. We have 2 equations to unknowns. How do you solve 2 equations to unknowns? You have 3 methods in mathematics and equations and unknowns. You have substitution method, However, before solving equation, I'll show you how to let's solve in general. Or you can solve based on question. You have two options. What is solving based on question? You go back to question. Okay, what was the question? Original problem plus here, minus here, V0. Question was V0. V0 is the voltage across 2 ohm. It's 2 ohm times. Don't change anything. V0 is 2 times I2, but I2 for V0, I2 for V0 goes from minus to plus. So you multiply by minus I2. You can't avoid this. If I goes through resistor from minus to plus, you still use Ohm's law. You just put minus I. You put minus in front of I or minus in front of voltage. Notice you don't have to go back and change anything. You're done with equation. So you solve this equation, you find I1 and I2 from the equation. But in order to, you go back to answer the question, V2 is equal to 2 ohm, but opposite polarity. So it's going to be minus 2I2. So you just need I2. If you need I2, you go to one of the equations. Let's say we have equation 1, equation 2. You can go to one of the equation. Hopefully regardless of your math background, you can solve two equation, two algebraic equation. You just need I2, you don't need I1. So get rid of I1. So for example, from equation 2, find I1, plug into equation 1 and find I2. Or just eliminate I1, multiply. Remember, in algebra, you can do it by substitution, finding one, substituting, two equations to unknown. Simultaneous, because if you have three equations, three unknown, four equations for unknown, then it's a little bit more tedious. However, general method of solving algebraic equation, especially when you have more than three equations to unknowns, it's a method called Cramer's method. Cramer's rule. What is Cramer's method? I'm going to apply Cramer's method in general, and then in this particular case, and then.
Wait, Professor, I had a question.
Yeah, go ahead.
So did you just change that minus, that plus to minus from minus to plus for V naught?
That was a given in the problem. That was, okay. Remember, that was the.
Oh, okay, I see.
That has nothing to do with it's not my option.
For sure.
Remember, this is the whole thing in blue color is my option. And I write my equation and I solve based on my own option. However, many times if you take EIT exam, they even give you loop current, they even give you polarities. You don't have to do anything. But in this case, they gave me clean circuit. So I assign everything. My point here is this method, mesh, is so systematic that if you use anything on your own, at the end, you just need to find mesh currents. Once you find mesh current, put them aside. Then go back and answer the question at the end. So at the end, I'm going back and answering the question with this V0. And this V0 is given in the problem. I don't have anything to arrange. Maybe from the beginning, you could have plus or minus around 2 ohm according to original question. But you don't have to do that. At the end, you just go back and V0 in the question with the voltage across 2 ohm that I assign, the same. Except that V0 in the question has opposite polarity. So I just put minus in front.
Okay, thanks.
Yeah. Okay, what is Cramer's method in mathematics? Now, this is math. This has nothing to do with circuit analysis. This is called Cramer's method. Let me show it in general. And then I don't want to erase anything yet. So what I'm going to do, I put Cramer's method here. Oh, sorry. Technique. Most of you are familiar. But let's say we have A1 x1 plus a2 x2. Actually, sorry, I don't want to do anything, but I want to match it with my, just in case it's, since I said you don't have to write anything, let me make it the same symbol as my handout. Let's say we have two equations. We have a1, v1. Again, v1 is just a dummy variable. You can have x1, you can have y1, doesn't matter. Plus b1, v2 equal to c1. Okay, I'm going to apply Cramer's rule to two equations to unknown. For this course, you have to reduce it to two equations to unknown because I'm not teaching linear algebra here. So I don't want to do anything with two. But Cramer's method you can apply to any equation unknown. Okay. You have two equations to unknown. However, I may ask you about 10 equations to unknown, 5 equations for 5 unknown, not to solve it, to do the correct setup. Okay, in this case, you have two equations to unknown. You define something called delta, and because you have two equations, delta 1 and delta 2. If you have 3 equations, 3 unknowns, you have delta, delta 1, delta 2, delta 3. If you have 4 equations, 4 unknowns, delta, delta 1, delta 2, delta 3, delta 4. So this delta with subscript depends on the number of equations. What is delta? Delta is a matrix. Even if you don't know linear algebra, just arrange coefficient of the left-hand side. That's why you have to bring all variables to the left-hand side. You have A1, B1. And row number 2, A2, B2, and put this symbol. This symbol means determinant. The determinant of 2 by 2, don't worry about 3 by 3. Multiply diagonal, subtract off diagonal. That's the meaning of determinant. That's your delta. Okay, that's the delta. So you define delta and you define the determinant. Okay, what is delta 1? Delta 1 is the same as delta, except for column 1. That's why you need to use the proper subscript. Delta is the same as delta. You copy delta. But then delete column 1. What do you put under column 1 is the right-hand side of the equation, C1. C2, the rest is the same as delta. So just write your delta, take column 1 and substitute by the right-hand side and find the determinant. It can be more systematic than this one. Then delta 2 is the same as delta, like A1, A2, B1, B2, except for column 2. So get rid of column 2 and substitute the right-hand side, C1, C2. So if you have delta 3, you substitute column 3. In this case, we don't have, but delta 3. Delta 4, you substitute column 4 with right-hand side. So what is your delta 2 here? It's A1, C2 minus C1, A2. Okay. Now the unknown voltage, V1, is delta 1 divided by delta, and unknown voltage, V2, or unknown variable, V2, is equal to delta 2 divided by delta. That's one of the most systematic method in algebra, using Cramer's method. So let's apply Cramer's method here. And you don't need to do anything. You just need to keep the variables in left-hand side and right-hand side. So in this case, we have two equations to unknown. So what is delta? Delta is just the coefficient in order. 13 minus 3, 3 minus 5. What's the determinant? 13 multiplied by minus 5 minus 3 times 3, and you simplify. Okay, what is delta 1? Delta 1 is the same as delta except column 1. So the second column is the same. The first column is the right-hand side, 3 and 8. Find determinant. It's 3 times minus 5 minus 3 times 8. And you simplify. Okay. What about delta 2? Delta 2, I'm going to write it here. Delta 2, again, it's the same as delta. So the first column is the same. Column 2, you substitute by the right-hand side, 3 and 8. So it's 13 times 8 minus 3 times 3. So I1 is equal to delta 1 divided by delta. I2 is equal to delta 2 divided by delta. Any question about mesh equation and Kramer method?
Professor, are you gonna?
Yes, go ahead. I'm gonna what? Sorry.
Are you gonna be doing another mesh equation example?
Yes.
Okay. Thank you.
I do one and then I'll continue with the class. I call you everybody to participate.
Okay. Thank you.
Okay. Let's go to the next example. Again, this is also from handouts. So you don't have to write it, just pay attention. 100 ohm. A current source here. Another current source here. Another current source here. Another resistor here. Okay, let's put values 50 ohm, 200 ohm. This is from textbook. 100 ohm, but it's in the handout. Then I have a 21 amp, 21 amp, 42 amp. The following, the question here is asking you to write, regardless of the question, write all mesh equations and find it. And find. I mean, and find it. Okay. Ignore the question. There is no question. I mean, the question here, in this case, it's all mesh equation. Identify simple loop. At this point, I don't go around the class because I want to quickly finish this one. So I asked in general, how many simple loops?
4 simple loops.
Four. Assigning, so we have 4 simple loops. So 4 mesh currents. Any direction. If it's given in the problem, use the direction. I'm going to use again. Then I do problems later that you choose direction. I2. I3, because I want to match with my note, that's why I'm using the same. I4. Then, how many passive elements?
Just 3.
Just 3. Assigning polarities. Again, any polarity. Anything. So in order to match, and don't label. Plus, minus, plus, minus. This one I'm going to use plus, minus. That's it. That's a preparation process. You have 4 mesh currents. You need 4 equations. Okay. You need 4 equations. You need to generate 4 equations. Okay. Remember in the guideline, I said use current sources first. Okay. Anybody has idea on how? Let's go to current source here. I'm showing with my pen. This current source. How can I use this current source to generate equation? This 21 amp. How do I use it?
It's contrary to the way that you defined I1, so I would guess that'd be a minus there.
So minus I1. First of all, check to
Minus 21 amp, I think.
minus, okay, this current source is shared. It's between two loops, loop 1, loop 3. So two currents are going in mesh, always you have two. If it's shared, you have two currents. Because it's loop. Okay, just move your hand. I1 is against. I3 is along. Just move your hand along I3. If I3 hits this source, it goes along the direction. So it's I3 minus I1 equal to the value 21 amp. This is your equation. You don't need any KVL. Let's go
So
to
that's
42.
That's your equation for I1, right? For the
Yeah.
first loop. Okay.
I3 minus I1 equal to 21 amp. That's the
Okay.
equation. Okay, that's why I said before you jump to KVL, see if you can, you may be able in mesh current. If you have many current sources, you may be able to get all equations without writing a single KVL. What about this current source, 42 amp?
I3
I2 is
minus
against.
I2
Yes,
equals 42 amps.
correct. And what about the 21 amp here, underneath here? This-
I4 minus I3 equals 21 amps.
Yes, good. I hope everybody else is also getting the. So I already have 3 equations. Yeah, go ahead.
I had like a kind of a, I guess I get kind of confused on how to define with what respect loop we're looking at. So like the first equation would be the top left corner loop.
You have to follow the direction of your loop through the source. So just move your hand. I1, let's say this is I1. It's just like a person walking. Like you're going around I1. When it reaches the current source, I1 keeps going, keep flowing. I1 goes against the direction defined by the current source. So it's minus I1. If you if you keep moving along I3 is along the direction. So it's I3 minus I1.
Yeah, but I mean, I see that, but I mean, we're defining the top left corner loop, right? I mean, that's, you know what I mean? Like, because I think the center loop, I mean, you can make an equation off of that, right? That would be just different from what we came up with for number 1. Or am I just
Why?
confusing everyone?
Maybe I'm a little bit confused about your question. The center one, are you talking about this one?
Yeah.
I4, again, this is shared between loop 3 and loop 4. So it's I4, and you have no idea what is I3, I3, they're all unknown. So this is between loop 3 and loop 4, has nothing to do with loop 1 and 2, it's 3 and 4. So I4, again, move I4, it's along the direction, I3 is the opposite. So it's I4 minus I3 equal to 21.
So in general, we're just concerned with the current sources? I mean, in this problem?
Yeah, in this case, yeah. No,
Okay.
I'm not done yet. I need 4 equations.
Okay. All right then.
Because
Thanks.
I have 4 currents, right? So we
Yeah.
have 3 current sources. Each current source gives you 1 information. I have 3 equations. I need 4 equations. The 4th equation must come from KVL. Okay, somebody from class, tell me, what KVL, which KVL should I use to write because I need 4 equations. Here with current sources, I came up with 3. I still need, mathematically, I need 4 equations for 4 unknowns. How do I come? The outer loop. Why not this loop? How do you write KVL? Because you pass through the current source. Current source voltage is not 0. But the current source voltage is unknown. You cannot relate by Ohm law. You have to write KVL when you can use Ohm's law. I cannot apply Ohm's law to current source. That's why I said bypass this loop. You always start with simple loop to write KVL. But this simple loop 1 is out because I hit this current source. Simple loop 2 is out. I hit the current source. The center loop 3 is out because I keep hitting these current sources. Loop 4 is out. I keep hitting the current source. So I cannot find any simple loop to write KVL. So what I'm going to do, I use the outer loop. Okay, for the outer loop, move in any direction. Again, movement is just rise, drop. Move any direction. If you move around the outer loop, you have drop, drop, drop. all three of them drop. So they're all, you have drop, drop, drop on one side equal to 0. Then you use Ohm's law. What is Ohm's law for 100 ohm? Move your hand. I1 agrees, passive sign, 100 times I1. What is Ohm's law for 200? I2 agrees, passive sign, 200 I2. What is the voltage across this 50 ohm? Again, move your hand. I4. There's only I4. The outer loop, these 100, 250, they only have one current passing through them. I4 also agrees. Equal to 0. You get 4 equations for unknowns. If they ask you just to set up the equations, mesh equations, you're done. But if they ask you to solve it, then it's the next step, the mathematical part. Any question here? How do you solve 4 equations for unknown? I mean, in order to solve 4 equations for unknown, if the question is given, if there is a specific question, just keep that variable. In math, they suggest several things, but the best is, in order to use Kramer, get rid of 2. For example, from here, you find I1 from here as I3 minus 21. From this equation, you find I2, for example, as 4D I3 minus 42. Okay, so you express I1 and I2 in terms of I3. Keep equation number 3, keep I3, so it's minus I3 plus I4 equal to 21. I shouldn't talk about the math process, but substitute I1 and I2, so you substitute 100 times I3 minus 21 plus 200 I3. This is just one of the options. Minus 42. You can use Kramer for 4 by 4, but again, many of you may not know the determinant of 4 by 4. Okay, what do you see here if you simplify 2 equations to unknowns? From these 2 equations to unknown, you find I3, I4, either by substitution or by Kramer method. And after finding I3, I4, you go back and substitute I3 here. You don't even need I3, I4, you just need I3. You find I3, I4, and then you take I3, substitute here, you find I1 and I2, so you have all the current values. Anytime you have multiple equations, it's probably better by substitution to reduce to 2 equations to unknowns, then focus on 2 equations to unknown, find the result of 2 equations to unknown, and go backward and find everything else. Okay, what I'm going to do, I put this example is in the handout, but I want the entire class participation. I'm going to use mesh and nodal both, depending on time, but I'm going to focus on mesh first, and then if there is any time left, then we also do nodal. And if there is no time, it's in the handout. This is a handout. Because of time, I want you to also start doing problem, homework assignment. Please, even if you feel lazy, you don't feel like it, this homework assignment is important, is a good practice, even if you still struggle to grasp the concept, still good idea to do this problem. Okay, this is a very, very, very good practice for both nodal and mesh. Especially mesh, because I just started mesh. I have 2 ohm, 5 amp, 16 volts, 8 I1 volts, and 3/4 V1 amp. Because you have a dependent source, you must specify the location of dependent controlling quantity. It depends on I1. Problem should give you. It's not up to you. This is I1. And And this depends on V1. V1 should be given. Where is V1? Let me double check. Oh, V1 is given here. This depends on V1. V1 is given. This depends on I1. I1 is given. Any question about the setup, the problem setup? This is a combination of dependent source, independent source, resistors, dependent current source, dependent voltage source, everything. It's included in this problem. That's why I said it's a perfect wrap-up example for both mesh and nodal. Since we are starting with nodal, since we are doing today we covered mesh, I want to review mesh first because we did enough nodal. And I go around class and I'm going to start from the end because I always do, just in case if we don't run out of time. Zaragoza.
Yeah. How's it going, Professor?
Yeah, I want to write mesh equation. So there is no specific question. So what should I do?
We should look for all the simple loops.
Okay, simple loop. How many simple loops we have?
We have 4 simple loops.
Okay. At this point, let's use the same because people may not have time to write this example. So in order to match my handout, I'm going to assign loop current according to my handout. So that way, just in case if you don't have time to write everything, you can go back and read it. Okay. So I'm going to use, otherwise, remember, you can use clockwise, counterclockwise, doesn't matter. I call this loop 1, so it's I1. Loop 2, by the way, if you take EIT exam, they give you loop current, I3 and I4. And then what is the next step to match, to assign what?
You want to assign polarities.
Polarities. Again, polarities only passive elements, 1, 2, 3. So I'm going to do assignment and don't label plus or minus. Plus or minus. This one, it's already plus or minus, so you just use it. And the reason I cannot ignore it because there is a dependent source. So I have to keep I1. I cannot ignore I1. So this polarity, red color, is the one according to the guideline. You don't have to, but I'm going to use the same polarity. Okay, Vivaldo, what's the next step for mesh? Vivaldo, are you here?
Yes.
Okay, what's the next step for mesh? I have all the loop currents, I have polarities, so what should I do now? First of all, how many mesh equations you need in this case?
4.
Because we have 4 mesh currents. Okay, in order now to write those mesh equations, what should I use first? Let's go to Villamel. Villamel, are you here? Velasquez, Ulysses.
Yes, I'm here.
Yeah, okay. I need to write equations, but I'm going to start with current sources.
Yes.
Okay, which current sources do I use? Let's use 5 amp.
The 5 amps, yeah.
Okay, so what current pattern do you see through 5 amp?
Is it the whole top loop we're going to use?
What current, mesh current, or currents are passing through 5 amp? This is more visual than even math. You look at 5 amp, what loop currents are passing through 5 amp?
I2.
Only I2?
And I4.
And I4. Which one agrees with which one agrees with current source?
I2.
Which one is opposite?
I4.
So what's the net current?
Is it I2 minus I4?
Equal to what?
5 amps.
Okay, so this is equation 1. Valencia.
Yes, Professor.
There is another current source, which is now dependent current source. What current is passing through that current source?
I3.
Does it agree or disagree with the direction of current source?
I think it agrees.
Why do you think? What makes you doubt?
That direct. No, yeah.
Is it-
integrate.
Yeah.
Excuse.
So
sorry,
what's
yeah,
the value?
integrate.
What's the value? What's the value?
So that one is I3. Okay, equals 3/4 B1.
Yes. You're not allowed to have V1, but don't worry about V1 yet. Just keep it this way. That's equation number 2. I'm out of current sources. So let's go to Tran, Raymond Tran. I need to apply 2 KVL. Which KVL you think is suitable? I need 2 KVL now. KVL 1 and KVL 2. Which KVL do you think, do you suggest, do you propose to write my voltage equation? Siordia, which KVLs? Siordia, are you here? Edith Siordia. You had mic problem before, you mentioned to me by email, but I have to hear your voice. You did send email about mic problem, but again, because it's a class participation, I have to hear. I'm making note of class participation. Samai. Abdul Samai.
Yes, I'm here.
Okay, which KVL I write my equation? Just write the KVL.
For KVL, so let's see.
Which loop?
For I4.
Loop 4?
Yeah.
This is loop 4. Is it feasible for KVL?
Can't have a current source, right?
Sabino. Unfortunately, people are not paying attention to lectures. Sabino, are you here? Sabino? First, let me go around and check how many people are listening. Rosales, then I'll go back and ask for your participation. Rosales, are you here?
Yes.
Rojas,
Yes.
Rojas, are you here?
Yes, yes.
Marlene Rodriguez, are you listening? Marlene Rodriguez. Marlene Rodriguez.
I'm here.
Janet Rodriguez.
Yeah.
Rosha, Daniel Rosha.
Here.
Vanessa Robles. Vanessa Robles.
Here.
Robin Rivas.
Here.
Alex Portillo.
Here.
Dominic Moreno.
Here.
Munis Sarahi. Pedro Munis.
Here.
Alexis Moreno.
Here.
Paul Monge.
Here.
Mandiola.
Here.
Melendez del Santo.
Here.
De Los Santos, sorry.
Right.
Macias.
Here.
Leon.
Here.
Aiden Lee.
Here.
Hermosillo. Haro.
Here.
Sebastian Gonzalez.
Here.
Jose Garcia.
Here.
Jose Garcia Sandoval.
Here.
Estrada.
Here.
Denley. Contreras.
Here.
Claire.
Claire.
Castro.
Here.
Abdul Casaneda.
Here.
Bernal.
Here.
Beltran. Jesse Beltran. Argondona.
Here.
Amador. Henry.
Here.
Alejandro.
Here.
Aguilar.
Here.
Hey,
Okay.
Professor.
Yeah.
I think Denley said that he or she was having problems with her mic too,
Okay,
or something like that. But she's here, I think.
okay. But Jesse Beltran not here. Hermosillo not here. Sabino? Ciordia?
Oh, I'm here, Professor. Sorry.
What's your last name?
Sabino.
Okay, and Villamil.
I'm here too, but I don't know if you can hear me because my mic is acting up.
Are you Villamil?
I'm Ciordia.
Ciordia. Okay.
Yeah, sorry about that.
Okay, no problem. As we get close to the midpoint, I have to make sure because remember toward the end, the absences they become. So that let me double check one more time. Jesse Beltran not here. Hermosillo not here. And then Villamil. Okay. Due to time, just want somebody open the mic and tell me which KVL is feasible KVL here.
The one going
One.
through I1.
One. Okay, it's a voltage drop. Just look at polarity drop, rise. Rise, drop, rise. So 4 ohm and source, 16 volt source, and 4 ohm. 4 ohm, I1 is passing through 4 ohm, opposite passive sign. It's a drop. It's a voltage rise, voltage drop, voltage rise, equal to the 2 ohm. What passing through 2 ohm? I1 and I2. I1 agrees, I2 is the opposite. That's KVL 1. What about the other feasible KVL? Anybody can find any other KVL that I can write my equation?
Wouldn't it be
Can you
that?
do the outer circle?
The outer circle, you're passing through a current source.
Oh, you're right.
You may have few options.
Can you supernode?
Yes. No, supernode has nothing to do here. But you can actually,
Like bypass?
in a way, it's like you can super loop. For example, let's say, let me use a different color, blue. I take this loop. You are not allowed to repeat it. This loop, for example, this is a loop. You have to find a loop. The only tricky part of this problem was to define a loop. I don't know what loop I use in my solution. But the point here is you can just KVL for the combined loop, for any combined loop. You can use this any situation. Okay, let's see. I just want to make sure that I3, I4, I want to make sure that I use the same in my handle. Yes, I use this one in my handle. Okay. So for this loop, have a quick assessment of rise and fall. Voltage rise, voltage rise, voltage rise, voltage drop. Only 4 ohm is drop. Everything else is rise. So what is this? It's 4 times minus I1 for this loop. Plus 8 lowercase I1, because that's a dependency. Plus 2 times what current is passing through 2 ohm? I4 against I3 along. So it's 2 times I3 minus I4. And then equal to 4 ohm, because for 4 ohm, we have, this is 4 ohm, sorry, 4 ohm. It's a voltage drop. It's 4 ohm times I2 minus I3. This is equation number 4. However, you have 2 problems. These are not mesh equation yet. Equation 1 is okay. Equation 1 is okay. This equation is okay. KVL 1 is okay. This is 1, 2, equation 3 is okay. Equation 2 and equation 4, we have two variables, V1, I1, that they are not associated to mesh current. I have to go back and check the location of V1. This is V1. What is V1? V1 is equal to 2 ohm, is the voltage across, times I3 minus I4. Anytime you have a dependent source, you need side work. I also need to get rid of lowercase I1. What is lowercase I1? I have to go back and check the location of I1. I1 is this current passing branch current passing through 2 ohm up, moving up. So I1 agrees with I2, and I1 is also passing its opposite. So I1 is equal to I2 minus I1. So I take this I1, plug it here. I take this V1, plug it here. Then I get 4 equations, 4 unknowns in terms of I1, I2, I3, and I4. Remember, your job as a circuit analysis person is to set up the equations. Solving is the math part. Your job is to set up correct and enough number of equations and unknowns. Okay, you have about 3-4 minutes to ask anything about this circuit. This circuit is the ultimate example of using mesh and nodal. Nodal, I did more examples last time, but this is just for mesh.
This is like as complicated as it'll get, like say on the test.
Yeah. I mean, test, I don't even give this one, but just instead of doing 100 problems, take this problem. It's just like a medicine, antibiotic that you take for 10 days, same thing. Use this example and repeat several times. For mesh, maybe even on your own, change the direction, the loop current, and write your own equation, because these are equations. Remember, if I change loop directions, my equation 1, 2, 3, 4, they're exactly the same. You must end up with exact same equations unknowns. However, if I change the direction of I1 and I2, eventually it's matching your direction. Like I1 here, when I end up and solve, if I end up with 2 amp, your I1 should be, if you use opposite direction, you end up with minus 2 amp. So just take this one as your core example for nodal and mesh. I can't think of anything, as you just mentioned, more complicated than this, or messier, or more confusing than this. The confusing part here is how to bypass, because each loop, if you use a simple loop here, is okay. But the simple loop has a current source, the simple loop has a current source, the outer loop has a current source. So you have to find something that you can bypass. What about, okay, for your other KVL, you can also this loop. You can, let me use a different color. You can also use this loop. That's also acceptable, as long as you find any loop that you start from a point, return to a point without repeating any element more than once, and then you don't pass through any current source, you can write your KVL. I can tell, due to not listening to the lecture, some of you still have problem with polarities and passive sign and everything. I can't do anything. I mean, you can just talk to the tutor, because it's something that you have to deal with if you still have problem with passive sign, non-passive sign. But just take this example and repeat several times. But do you have any question for this particular example? The current sources are easy. This KVL should be easy. And then my outer KVL that I use this, I mean, I use portion of the outer, then when coming back, I use this path, rather than I bypass the current source here. So I use the voltage source and 4 ohm here. And this KVL shouldn't be any problem. This is chapter 2 material. It's a voltage drop, voltage rise, and in this case, going from minus to plus. Voltage rise, minus to plus, voltage rise, plus to minus, voltage drop, minus to plus, voltage rise. So as long as you understand that the 4 ohm volt, the dependent source volt, the independent source volt, they all appear on one side equal to 4 times its current on the other side, then for each individual resistor, just use Ohm's law. If the current agrees with passive sign, put plus in front. If the current is opposite passive sign, put minus in front. If the branch is between, any element is between 2 branches, then you have 2 currents passing. So you have to consider both of them. Only the elements located along the outer pathway, they have single current. Any element inside has 2 currents, always has 2 currents. So you always have to consider both according to the direction. Any question?
Yeah, Professor, I had a question.
Yes.
Passive sign convention was kind of messing me up on how you got lowercase I1 equals to capital I2 minus I1.
Say it again.
The passive sign convention rule was kind of hard to see on how you got
this is for
I1
all?
equals to I2 minus I1.
I1 equal to I2 minus I1? Where did I,
Yeah.
where? Oh, this one? Okay. Okay,
Mhm.
this is I1, sorry. Okay. Now let's focus. I'm going to focus on this branch, okay? So maybe this is the branch, 2 ohm branch. This is 2 ohm branch. Okay, what is my loop current? I1. Right. What is the other loop? Because this is a branch between loop 1. This is I2, right? What is I1 given by the problem? Because this is given by the problem. So what is given by the problem? I1 going through 2 ohm from lower point to the upper point. This is given by the problem because it's controlling the dependent source. How I1, lowercase I1, uppercase I1, I2 are related? Okay, I1 is going up. I2 is also going up. I1, uppercase I1 is going down. So what's the relationship? Lowercase I1 is I2 because it agrees, it goes up and up, minus, what's the net current? Net is going up. So what net goes up? I2 minus I1. If I had I1 opposite direction given by the problem, then I1 was, lowercase I1 was uppercase I1 minus I2. So anytime they give you a dependent source with controlling quantity, that controlling quantity is defined by mesh current according to the arrangement of the mesh current. This is given by the problem, it's going up. So I2 goes up and I1 goes down. So it's I2 minus I1. If I had this situation, let's say we had 2 ohm, let's say they gave you I1 here. This is a different example. Let's say we had this case. Let's say this is I1, I2. So what's the relationship in this case? I1 is going up, but I1 and I2, they both have opposite. So it would be minus I1, minus I2 in this case. It's just like a current source. Anything that it's matching given direction, you put plus in front. Anything that it's opposite the given direction, you put minus in front. Any other questions?
Thank you so much.
Okay. I think if you have any question, you can stay and ask question. Otherwise, this is mesh. Please try to solve problems. You can solve all homework problems now, homework number 4. Some problems I ask you to find the answer. The last 2 problems is just a setup. Find a setup. Remember, when you set up mesh equations or nodal equations, especially when you have a dependent source, at the end, your equations, they must include only your mesh currents. Notice in this case, I1 wasn't mesh current. I1 was individual current. Also in my equation, I had V1. You're not allowed to keep V1. V1 is not. V1 should be replaced in terms of mesh current. Nodal, you have voltage. Or you must have your final form in terms of voltages only. These 2 methods I mentioned many times. They are the backbone. Like basis structure of any circuit analysis. If you take power classes and you have to write mesh equations when you have transformer, going from transformer to transformer to transformer, then you appreciate mesh. If you take electronics and you have to write equations when you have electronics elements with nodes going all over, then you may appreciate nodal. Anyway, if you have any question, please ask. Otherwise, have a good day.
I have a random question.
All right,
Yeah.
Professor, thank you.
Okay, do you have any questions? Somebody has a question?
Yeah, just a
I
random one. For polarities, what if we we choose our own polarities, right? For the
Yes,
negative-
yes. If it's not given, you choose it. So at the beginning, remember for preparation process, you have options for two things: loop current, any direction you want, and polarities. But once you assign direction and polarities, you keep them.
Okay.
And notice that loop currents, they should not agree with each other. For example, you can choose loop current for one loop going in clockwise and the other one counterclockwise direction. Absolutely no restriction on that.
So then we'll have different answers for current and stuff, right?
No, that's the point here. You may have different looking equations. However, when you solve them, that's why you may have appearance-wise, like for example, if I choose a different loop, of course, I don't have equation 4. I have a different equation, different looking equation. But the point here is, if you solve them numerically all the way to the end, answers are the same. Like for example, if I ask you to find a voltage someplace, let's say find I1, for example. Regardless of your choice, regardless of your selection, you end up with 4 equations for unknown. That's why your nodal equation, your mesh equation must match the polarity and directions that you're showing to me. You're right. If somebody else has a different showing of current or polarity, they have a different looking equations. So
Okay.
that's why in the exam, if I give you the exam, I have to assign for the sake of grader, because grader should check each set of equations for each choice. That's very time consuming. However, my point here is, regardless of whatever you choose, this is circuit analysis. If you solve your whatever you like to assign your mesh current, when you find your mesh current, when you relate them to I1, the I1, which is the question in the problem, going up at the end, passing through to all, any choice ends up with the same value for I1.
Okay, awesome. Thank you.
Okay. Any other question? Okay, have a good day.
Yeah.
Yeah, go ahead.
Mine's kind of long. Do you have time for that? It's
Is
not
it
even
a-
regarding this. It's regarding nodal rule.
What I have another class. Let's see. What time is it now? I cannot see.
10:48.
Oh no, in 1 minute I have another class. I have back-to-back classes, unfortunately.
No,
You
it's
can,
okay.
okay, you know what? You can ask by email,
Okay.
or you can ask at the beginning of class next time.
Okay. Then. All right. Thank you.
If it's not, okay, no problem.
Bye.